I'm gonna talk about today, it's a paper that I started writing with another colleague of mine. Well, actually, a kind of like external consultant. I will give you the information afterwards. Let's this. And basically, the idea is just a couple of words about the robotics evolution and how does it fit, basically, with what we're facing now. Which is the link between robotics and cyber, and which are therefore the possible risk that we see rising as well as robotics changing. And also the importance, because there are two main aspects that have been kind of like neglected in the narrative about robotics lately, which are cybersecurity and digital forensics. I have to say that, and this is kind of also an invitation for you, because if you have any material, if you have any good source, please let me know, because it was kind of like difficult. Usually robotics are kind of like associated with, for example, automation, so industrial control systems, but they're not exactly the same, and we will see it why. And also which are, let's say, the possible answers to give to digital forensics and cybersecurity challenges. And we will see a couple of cases. Why it's an emerging field of technology? Well, first of all, because you have to think that it's getting more and more cheap. All the devices that we started wearing have some of kind of like these elements of the Internet of Things or Internet of Everything things, and they are getting more and more sophisticated, but we don't know it. Imagine, for example, the phone. I remember my first phone was a Nokia, I don't remember the code. And it was funny because when I was living in Canada, it happened to me that it went into the toilet, basically. And I took it out and it was working. But for making it work, I had to open it and you knew what there was inside. How many of you have opened an iPhone, for example? How many of you have opened one of this? I mean, not so many people, because on one hand, they are getting more powerful and also more useful, but on the other hand, they are getting easier for the user. And it's the same thing with robotics. I have the example, when I was checking the first example of robotics, one was the pedometer. Kara, it's pedometer? Yes, okay, thanks. So basically the thing that is used to counting the steps that you are doing. Nowadays, who is using a pedometer anymore? Everybody's using like the health app of the phone, okay? Or we are using like Fitbit and all these kind of different devices. They have an element kind of like of robotics, but we don't recognize it as that. And we see that it's basically getting more and more into our life, till going into real, like for example, humanoid robots, or we've heard a lot about, for example, military robots, okay? I decided to have an example of a drone, and we will see why. But they're getting more and more into the news. What happened regarding the evolution? Okay, back in the day, we had the first industrial revolution, where we started seeing mechanical products. Then we had the second industrial revolution, where we see that the mechanical production went massive. Okay, so we had mass production, and we had one game changer that was the electrical energy, okay? And then we have a kind of like a third industrial revolution that was the one that we got used to, sort of, with the use of electronic and the use of IT systems, and also the starting of the automation and the starting of the automated production, until going to the last, the industrial revolution, which is basically the interconnection, I would say, the mixing between cyber and physical systems. How many of you have a Roomba? Do you know what a Roomba is? Really, you have a Roomba? I want to see it. I will try, because as I mentioned to you, what I'm doing in Unicre now is working on the misuse of technology. And when I was thinking, okay, I need really to find an example of misuse of technology. Let's see if it works. Well, actually, this is a good example. And by the way, if you try to Google Roomba plus cat or plus baby, and the word gets crazy, really. I was kind of like frightened at one point, and so I stopped searching. But basically, we have machines that are kind of like autonomous. And they are born for doing stuff, in this case, cleaning up the floors, but they can be used for other several things. And even if maybe we don't recognize them as robots, the expectation for the next 3 years, so until 2017, is to have, well, the estimates are about 31 million units of service robots for personal use. And among service robots, I mean, this is an example, but I mean, if you digit like service robots, you will find a lot of different other examples. And again, basically, it's a machine that we put in our house. And on the other hand, there's also another important element, that most of these machines are connected to the internet. And not only to the internet, but they are interconnecting with all our different devices that we have. In general, we see that, as I mentioned before, since it's getting cheaper and cheaper to build robots, and it's a kind of like a big investment for several industries and for several countries, we see that definitely the sales are growing up and up. And for example, I was really like shocked by the different estimates and the forecast that we have. For example, China, see how much they are investing, basically, and how much they think they will be growing about 2017. Europe has a lot of initiatives. I don't know if you have heard about them, but they have a lot of initiatives on robotics and specifically on developing. For example, they have a lot of startups that are dealing in this moment with robotics, and North America as well. But China is definitely, in I would say, Asian countries in general. I was reading a lot of studies related to Japan, for example, where they are testing and already some sort of like humanoid robot. For example, all these issues related to taking care of the elderly people, they are trying to solve, let's say, the problem with robot care. And then there's clearly the defense industry. The defense industry is one of the industries where we have the biggest investment. And these are just the pictures that I randomly try to look for. One is examples of robotics in Afghanistan. Here it's Korea. We have, well, drones are definitely used a lot. And also robots, they are testing robots to, for example, rescue military. So rescue soldiers that have been hurt, for example, in the fight, and so to take them away from dangerous situations. And regarding robots, yesterday night I was discussing with a guy dealing with machine learning. And I'm not going to touch this in the presentation, but it's true that there's all this discussion about the ethics and about, for example, there's a big campaign now about stopping killer robots because one of the issues is to what extent they are able to make decisions, to what extent, and especially in military settings, it went out with drones, and which is the responsibility, for example, for the pilot, and who is giving really the instructions. Has the drone or some sort of robotics, imagine, for example, that case, that we feel like very human, to which extent they are able to take their own decision. And at one point, having worked in this field for a long time, the first thing that came to my mind is, but what if we hack a drone? I mean, what if it's not a matter of for him or her or it to take a decision, but we basically interfere with the system. And as I mentioned, the projections for the manufacturing for the robots are really incredible. I mean, if you check, it's not a topic, I showed you before some news, some headlines. It's a topic that for the moment is just kind of like gossip type of news, meaning, oh, you've seen this humanoid robot and these kind of things, but it has a serious impact on our economy, and it has clearly serious consequences. As I mentioned to you before, I gave you some examples of elements, just to understand that it's not something that we need to perceive as so far away from us, but most of the devices that we are using today might be considered robots, like intelligent devices, intelligent systems of systems, and they are all basically part of what we are currently living, which is the Internet of Everything. What's the problem now? As I mentioned to you, the problem is that those systems are, as all the various cyber-physical systems, can be hacked. And this morning, I was explaining how the new threats, the new challenges are strictly related, for example, to the Internet of Everything. And for several reasons, and I remember when I was discussing these issues at the very beginning, and you remember when there was the transition between the IPv4 and the IPv6, okay? And there was all this thing about, oh yes, now the fridge will have IPv6 and these kind of things. And everybody was telling me, oh yes, but do you know how your fridge is made? And I was like, no, you're right. But my point is that up to now, I've never shared my personal data with my fridge. Okay? Now we are sharing personal data with our fridge. With our fridge, maybe we share the health app, okay? And we know that maybe we need to go shopping because something is missing. And not only with the fridge, but think about connected cars, for example, okay? Again, a lot of people telling me, oh yes, but you don't know exactly all the pieces that are the components of your car, which is totally true, but again, I've never shared my personal life with the car. Nowadays, starting from the Bluetooth on, okay, when you enter into a car and you connect your phone, all your life is going through your car, to give you an idea. And therefore, all the different devices are all interconnected. So it's not just a problem of the robots in itself, which might cause, clearly, damages, and we will see them in a while, but it's also a matter of the relationship that we will have with this type of technology. Which is the convergence between cyber and robotics? At the moment, unless in some military environment and the information are not exactly public, we have two main cases that went public, and they are up to now quite related to research from different researchers in a couple of universities. So at the moment, they are at the proof of concept stage. And I decided to take these two examples. One is the Maldrone, which is the first drone malware identified. And the other one, it's called as Raven 2, because it's the basically the first attempt to hack a teleoperated surgical robot to basically show the security flaws. The Maldrone. The video is kind of like long, so I won't show you all the video, but in any case, you will have the references here. And the video is nice because it's this guy that is explaining how he hacked the drone, and you will see it flying, and you will see it before and after the hack. Basically, it's a vulnerability to be hacked via backdoor, inserting the malware into the navigation system. So attacking basically the GPS and the possibility to understand the spatial information. The malware, what happens is that creates a proxy between the bot and the drone. And the proxy allows basically the bot to take full control of the drone or also to kill the drone. So it's not only, up to now what we've seen are the first things that come to your mind is, okay, we can shut down the drones, which are attempts that have been already out. For example, I remember, I think it was at Black Hat, but I need to check it, that there was a kind of like example of shutting down drones for, as a proof of concept. But it's also possible to change their direction. And since we are more and more discussing about the possibility to have armed drones, the point is attacking their possibility to make decisions regarding who to shoot and not to shoot. So it's a kind of like mixture between what I was explaining before about the ethics of decisions and the possibility to interfere with this sort of like ethics and to severely interfere with the system in itself. And at the moment, the testing says that it can work across a different variety of civilian drone types. As I mentioned to you, the military ones are still kind of like classified material. I was at a closer meeting with the army in Italy, and I was kind of like glad to know that they are trying to consider also not only the physical security and not only to train the pilot, because now there are more and more training for the drone pilots, but also to understand that there are risks that are not strictly related just to the physical dimension, but they come across the cyber and the physical one. And then the case of the medical telerobot. The medical telerobot is this Raven 2, it's called. The University of Washington, a pool of researchers of the University of Washington, they've been able to hack into a teleoperated surgical robots, and I really encourage you to see the video. It's kind of like creepy. And basically the idea was that you will see the arm of the robot that is kind of like doing a fake operation, and how the researcher were able to change the instruction and to make the robot behaving in a different way. The problem is that the communication interface links the surgeon's PC with the telerobot on the open internet. That I know many of you that are working in the security community would smile at this point, but at the moment, most of these technologies are using basically the open internet, and so not private network. And the idea is very good, because we have more and more problems, and there are also a couple of cases in Italy, and specifically in an hospital where I live, in Torino, where they showed how it's possible to have a sort of like remote surgery operation, which is fantastic and very fascinating, and clearly it can improve the life of a lot of people, but on the other hand, it also poses a security risk. The type of attacks were simulated. Okay, so at the moment it's just a testing environment, and they try to have an effect on changing basically the operator commands. So you see the arm of the robot like having jerky movements and losing basically the control. Modifying the degree of command, so changing, for example, the distance or the direction, and usually in telesurgical robots you need to be extremely precise, and you will really see that giving different inputs and coding in a different way, it moved in a kind of like awkward dimension. And also there's a part of the video that is showing how they were completely taking control of the communication protocol. Basically a sort of like virtual DDoS attack was carried out by incapacitating the robot, because basically they were floating it with a different type of attack and of different comments, and at one point the robot went completely crazy. And again, it's a sort of like scary if you think that it's something that can actually happen. And okay, before we were laughing about the Roomba, and the Roomba can have relatively small impact on our life, and especially on our safety and security. This type of robots can have definitely a different impact. What I said before is that the robots are not conceived with security and specifically with the possibility of having digital forensics in mind. What I'm saying is that at the moment, the focus have been posed in the advancement of technology. We need better technology and we need it cheaper. Okay? So at the moment, the manufacturer focused on the possibility to have very good products that can work in a very easy way and the most user-friendly possible. But not so much attention have been posed, as I showed you before, to the cybersecurity aspects and also to the digital forensics aspect. And digital forensics is very important because when you have a robot malfunction, and relating to what I was saying before about the ethics, so who is taking the decision, who is responsible? Who is responsible in, well, the normal discussion is who is responsible if the command that you are giving to the robots are the wrong ones? So who is taking responsibility? But in this case, it's even more complicated because the point is who is taking the responsibility if the robot gets hacked? And how you can trace it back. We very well know that we have a huge problem in the information security regarding attribution, for example. Here you link, let's say you add the attribution problem to something that has a severe physical impact, that might have a severe physical impact. And for example, the standards, let's say, digital forensic procedure, help in understanding if it's a problem of, I don't know, software compatibility, or if it happened a cyber attack. I mean, if it's a problem of malfunction, let's put it in this way, or it's because there was a kind of like external interference. Also, it's very important to understand if there were system bugs, and in case of system bugs, like in the case of the Maldron finding the backdoor, the point is how can we prevent this event to happen? There are some kind of like steps that we need to take for both. I would put them together, like cybersecurity and digital forensics. We need money, for sure. And as I mentioned before, a lot of research has been put in making robotics accessible, more accessible to a lot of people. Maybe there should be also more investment in making the robotics secure and accessible. Also, I know, I mean, before Cara, she said a very important thing, like you cannot have 100% security, never, in any case. But it's also true that there might be some type of like security by design, security by default attempt, at least. And this would be an interesting field to see the first let's say, attempt to have this kind of like security incorporated in the design of the machines. And also the point is, as usual, I would say, in an environment that has cyber in front or integrated, is do we need more laws? Do we need a new one? Do we need more regulations? I think we're not at that step yet, but this is something that we should take into consideration. And there's an interesting debate in the United States. I don't know if you have ever heard of him. His name is Ryan Calo. And Ryan Calo even got to the conclusion that we need a sort of like, we might need a sort of like a federal agency for robotics because it's such a big thing that it's happening that we might need an ad hoc body within the government to deal with this type of technology and to deal with a certain type of regulation that are strictly related to the nature of robotics in itself. Here I'm just like suggesting possible standards and best practices in digital forensics because as I told you before, there were not so many documents dealing with, not so many researches dealing with digital forensics in robotics. And so, I mean, there are some international guidelines, well, the IATF guidelines, there's the ISO standards, and also a relatively interesting guidelines that are coming from 2013 from the Scientific Working Group on Digital Evidence. So we try to understand which are the possible measures that are applicable also in the case of robotics. I leave you with questions and challenges more than answers. As I mentioned to you, we are at the kind of like a first stage of the research. So if you have any suggestions and inputs, please send them to me. First of all, the assigning responsibility part. So who is liable after an attack on robotics technology? The problem is that it's not just a risk that is related to the manufacturer, for example, or to the person company that is giving the control, or, for example, to the pilot of the drone in that case. But we need to have a sort of like a multi-sector awareness campaign that understands the risk to have a cyber and physical environment getting together. There's a need for more information sharing. I think it's the third or fourth time that I'm saying this, even if the topic of the two talks were very different, but still, it's one part that we are still kind of like lacking and being good at. For several reasons, also because there's a kind of like big imbalance between the interest of the public sector and the interest of the private sector, which is a big thing. And then on the other thing, it's also the different interests that the private sector might have among themselves. We need also to have the law enforcement aware of this. Up to now, only the army have been involved. But more and more, due to the fact that this type of technology will be used by normal people, okay, not just by soldiers, not just by army deployed in conflict situations. We need also the normal, I would say the civilian law enforcement being able to understand and deal with that. Imagine, I mean, I always say that even though I like the idea to have like task forces and super cops and these kind of things, I think that one of the biggest problems that we have in this moment with the law enforcement and the digital forensics capability is to enhance the threshold. I would like to see many more law enforcement people being able to deal with digital forensics, because nowadays with every type of crime, you will have to seize a phone, to seize a laptop or something like this. Imagine, I mean, we might need to seize a drone. It's exactly the same thing. And there's a totally another level of discussion, which is basically the relations between states. And if there's a kind of like role for the international community to address and to regulate the proliferation of robotics. As I mentioned to you, many questions, not so many answers, unfortunately, up to now. But I think it's a very challenging environment, and it's and studying it, I think it's much closer than what we perceive. It's not just something that we read on the news, but it's something that might happen, let's say, in our life quickly. So, if you have any questions, these are my contacts. Thank you.
Thank you very much.
Thanks a lot. Oh, thanks.